Welcome to your personal deep dive. We've got a really fascinating one for you today. You've been exploring the world of large language models lately, sending over a really interesting mix of research papers and articles. We're focusing in on one paper in particular that caught our eye. It challenges some pretty big assumptions about what makes an LLM successful.
Yeah, that's right. For a while now, the prevailing wisdom has been um, bigger is better. The idea that scaling up model size and training data just automatically leads to better performance.
You're right.
This paper, it's called Not Just Scaling Laws, towards a better understanding of the downstream impact of language model design decisions. It takes a closer look at that assumption, and well, it uncovered some surprising findings.
Okay, so let's dive into this. The paper analyzes 92 different open source LLMs. They range from a relatively small 11 million parameters all the way up to a massive 110 billion. So what exactly were the researchers trying to figure out with this analysis?
Well, they were really on this mission to decode LLM performance. Like
Huh.
they wanted to understand what truly drives how well an LLM performs across different tasks. And what they found is that it's not just about size. You know, design decisions, particularly about the types of data an LLM is trained on, can have a huge impact.
Okay.
Like we're talking a potential performance difference of 3% to 28%.
Wow, that's a pretty significant difference. So what kind of data choices really stood out to you?
Well, one of the most fascinating findings, at least to me, is the role of code in the LLM's training data.
Yeah.
You might think that more code equals better performance across the board, but it turns out it's not that simple.
Yeah, that was kind of my initial thought too. More code equals more skills, right?
Not necessarily. What they found is that LLMs trained with a high percentage of code data, they do really well. They excel at those coding-related tasks. For example, they aced the human evil benchmark, that one that measures a model's ability to actually write code. But here's the catch. Those same code-heavy models often struggle with more nuanced language tasks. Things like, natural language inference or understanding those subtleties of human communication.
So it's like they become super specialized coders,
Right.
but they lose some of their ability to grasp the nuances of human language.
Exactly. Yeah, it's a trade-off. And what's even more interesting is that the sweet spot for code data seems to be somewhere around like 15–25%. This finding really challenges the assumption that just throwing a ton of different data types at an LLM, what's called multimodal training, will automatically make it better.
Right. So it's like there's a delicate balance to strike when it comes to data composition. Too much of a good thing can backfire, even when it comes to data. So code was a big factor, but were there other data choices that had a noticeable impact?
Absolutely. Yeah, while code had the most consistent effect, other choices mattered too, though not as dramatically.
Go.
For instance, LLMs that were trained heavily on like question and answer style data from sites like Stack Overflow or Quora, they tended to excel in those knowledge-intensive evaluations like the ARC challenge. It seems that the specific, I guess you could say, flavors of data within broader categories like web, code, or books can really fine-tune an LLM's skill set.
So what you're saying is that building a successful LLM isn't just about throwing a massive data set at it. It's about understanding those subtle connections between the training data and the LLM's abilities.
Exactly. Yeah, this research really, it pushes us to move beyond simple scaling laws and really consider the nuances of data composition when we think about LLM development.
Yeah, this is giving me a whole new perspective on how to evaluate LLMs. I'm realizing that I need to ask more questions about the training data. It's not just about knowing whether an LLM was trained on code, but also what kind of code and how much, and what other types of data were in the mix.
That's a great point. It's about understanding the recipe, so to speak. And that actually leads to another fascinating aspect of this paper, how the researchers use the LLMs themselves to reveal clues about their training data.
Hold on. We can actually use LLMs to tell us what they were trained on. How does that even work?
It's through a technique called free generation. Essentially, they gave the LLMs a blank slate and said, go generate some text.
Wow.
By analyzing the style and content of what the LLMs produced, the researchers could get a sense of the types of data they had been exposed to. It's kind of like analyzing someone's writing style to figure out what kind of books they read or what kind of conversations they have.
Okay, that is seriously cool. So we can get a glimpse into the LLM's mind by looking at what it chooses to generate.
Exactly. It's like having the LLM tell us its own story.
Yeah.
And within that story are clues about its training data and ultimately its capabilities.
This is blowing my mind. We've just scratched the surface of this paper, but it's already clear that building a successful LLM is far more nuanced than just focusing on size. It's about making informed decisions about data composition, understanding the trade-offs involved, and even using the LLMs themselves to help us decode their inner workings. But before we go any further, let's pause for a moment and let you, the listener, absorb all of this. What are your initial reactions? What questions are popping into your head? We'll be back in a flash to continue our exploration of this groundbreaking research.
Welcome back. We've been talking about how data composition really shapes an LLM's abilities. When I think about data, my brain immediately jumps to those, massive data sets scraped from the internet, tons of text, code, images. But this paper made me realize it's not just about the sheer amount of data, it's about understanding the different flavors within those broad data categories and how those nuances can really affect an LLM's performance.
You've hit on a really crucial point. It's like, baking a cake.
You can't just throw all the ingredients together, haphazardly. The
Yeah,
type of flour you use, the quality of the chocolate,
right.
those subtle variations, they matter. And it's the same with LLMs. The specific sources within those broad data domains can significantly influence the model's strengths and weaknesses.
Okay, so I'm getting hungry thinking about cake now. But I'm even more intrigued by this idea of data flavors. Can you give me a concrete example of what you mean?
Absolutely. Let's stick with the code example since we were talking about that.
Okay.
Imagine you're training an LLM to be a coding whiz. You might include code from GitHub repositories, Stack Overflow discussions, even like snippets from coding tutorials. But each of those sources brings a slightly different flavor to the mix.
Yeah, so like a snippet from a well-documented open source project is going to be different from a rushed answer on Stack Overflow.
Exactly. Yeah, and those subtle differences matter. The researchers found that LLMs trained on code from those well-documented projects, like you mentioned, tended to generate code that was more readable, easier for other programmers to understand.
Okay.
On the other hand, models trained on code from less organized sources.
Yeah.
Think like quick and dirty solutions just posted online. They often produce code that was more efficient but less transparent.
So it's like the LLM is learning not just how to code, but also a particular coding style based on the data it's been exposed to.
That's a great way to put it. And this principle applies like across different data domains. For instance, LLMs trained heavily on news articles might excel at summarizing events, extracting key facts, but they might struggle with tasks that require more creativity or emotional intelligence. Like their language might be very factual and to the point, lacking the nuances of humor or storytelling.
Right. So if I'm building an LLM to be a chatbot, I might want to train it on a data set that includes more conversational language.
Hmm.
Things like, movie scripts or plays.
Precisely. Yeah. The key takeaway here is that data composition isn't just about gathering, as much data as possible. It's about carefully curating a data set that will enable the LLM to excel at the specific tasks you have in mind. It's about matching the data to the desired outcome, just like a coach would design a training regimen for an athlete based on their goals.
This is making me think about all the LLMs out there and how little we actually know about the data they were trained on. A lot of that information is kept, under wraps, right? So how can we get a better sense of what went into these models, especially if the details aren't publicly available?
That's where that free generation technique we discussed earlier comes in.
Right.
It's a surprisingly powerful tool for kind of, peeking behind the curtain, so to speak.
Uh-huh.
Remember, we give the LLM a blank slate and let it generate text freely.
Right.
By analyzing the style and content of this, like freely generated text, we can start to infer what kind of data it was exposed to during training.
So it's like a linguistic fingerprint. Like the LLM's writing style reveals clues about its training data.
Exactly. Yeah, and the researchers found that this technique was surprisingly effective at revealing those, hidden data sources. For example, models trained heavily on web data often generated text that was more informal, even, slangy at times, reflecting the casual language often found online.
That makes sense. It's like those models picked up the internet's like conversational quirks. So does this mean that anyone can analyze an LLM's output and just figure out what it was trained on, even if that information isn't publicly available?
Well, it's not, foolproof, of course,
Oh, okay.
but it is a powerful tool for gaining insights into an LLM's origins and, potential biases. And as we discussed earlier, understanding the training data is crucial for evaluating an LLM's strengths, weaknesses, and even its potential for bias.
This is making you wonder about the future of LLM development. If we know that data composition is so crucial, does this mean that we need to create like specialized data sets for every imaginable task?
Well, it might not be that extreme, but it does mean that we need to move beyond the bigger is better mindset and think more strategically about data curation. Can we adapt existing data sets for new tasks? Can we combine multiple data sets in a way that, maximizes an LLM's capabilities? These are some of the, I think, key questions we need to consider as we move forward.
So it's not just about gathering more data, but about using the data we have more intelligently. It's about becoming like data chefs, carefully selecting and combining ingredients to create the perfect LLM recipe for each task.
That's a great analogy. And this paper is like a masterclass in, data cuisine,
hmm
providing those valuable insights into how different data flavors can shape an LLM's abilities.
This has been incredibly insightful, but I'm curious, does this research shed any light on those like more philosophical questions about LLM behavior? Things like creativity, intuition, or even consciousness?
Those are some big questions,
Yeah.
that researchers are still grappling with. While this paper doesn't provide those definitive answers, it does offer a framework for thinking about them more rigorously. The fact that we can now use LLMs to, reveal their training data, analyze their writing styles, and even pinpoint how specific data choices influence their behavior, it brings a new level of transparency to the field. It's like we're gaining a deeper understanding of the LLM mind. And that could ultimately help us address those bigger questions about, the nature of intelligence and consciousness.
This research has given me a lot to think about, and I'm sure our listeners are feeling the same. Let's take another pause here to let all of this sink in. What are your biggest takeaways from this segment? What questions are bubbling up for you? Jot down your thoughts and we'll be right back to wrap up our exploration of this fascinating paper. Welcome back to the final part of our deep dive. We've talked about the importance of data composition, but this paper also highlighted something else that really caught my attention, and that was how even subtle architectural tweaks can significantly impact an LLM's capabilities. It's a good reminder that it's not just what you feed the model, but also how you build it.
That's right. Yeah, it's like fine-tuning a race car. You might have the most powerful engine, but if the suspension is off or the aerodynamics aren't quite right, you won't reach your full potential. And this paper dives into some of those like seemingly small architectural choices that can actually make a big difference in how an LLM performs.
So, okay, walk me through some of these like architectural nuances. What kind of tweaks are we talking about here?
Well, one example that stood out to me was the type of layer normalization used.
Okay.
Now, I know this might sound a bit technical,
Right.
but bear with me.
Okay.
Layer normalization is essentially a way to keep the LLM's internal computations stable during training. It's like making sure all the instruments in an orchestra are playing at the right volume so you can hear each part clearly.
Okay, so it's about balancing the signals within the model. But I'm guessing it's not as simple as just turning a volume knob up or down.
You're right. Yeah, there are different types of layer normalization, each with its own strengths and weaknesses. What the researchers found is that a specific type called RMS norm, which is kind of a slightly simplified approach, actually worked particularly well for tasks involving long-range dependencies in text.
Okay, break that down for me. What do you mean by long-range dependencies?
Well, imagine trying to understand a complex legal document or a scientific paper. You need to be able to connect ideas that might be separated by, like, several paragraphs or even pages.
Right.
Those are long-range dependencies.
Okay.
RMS norm seems to help LLMs see those connections more clearly, leading to better performance on tasks like summarizing lengthy documents or translating texts that require understanding subtle nuances across sentences.
So the choice of layer normalization technique actually impacts how well an LLM can, like, grasp the big picture, how it connects the dots across long stretches of text. It's like, choosing the right lens for a camera depending on whether you're shooting a close-up or a vast landscape.
That's a great analogy. And another architectural detail that stood out was the choice of positional embeddings. These are essentially markers that tell the LLM where each word is located in a sentence, which is crucial because word order matters a lot for meaning.
Right. The cat sat on the mat is very different from the mat sat on the cat.
Exactly. And just like with layer normalization, there are different techniques for creating positional embeddings. The researchers found that a technique called rotary positional embeddings worked particularly well for tasks that involved understanding like subtle relationships between words.
So it's not just about knowing what individual words mean, but also understanding their relationships and how they function within a sentence. It's like
Yeah.
understanding grammar and syntax, those underlying rules that give language its structure.
You've got it, yeah. Rotary positional embeddings seem to give LLMs a better grasp of those underlying rules, which leads to improvements in tasks like parsing complex sentences, understanding pronoun references, and even generating more grammatically correct text.
It's amazing how these seemingly minor architectural choices can have such a significant impact on an LLM's abilities. It makes me wonder if we're only scratching the surface of what's possible when it comes to, like, fine-tuning these models.
I completely agree. This research is like a toolbox for, LLM architects, providing insights into how different design choices can be used to create models tailored for specific tasks. And as we continue to explore these possibilities, we're bound to uncover even more, you know, surprising and nuanced connections between architecture, data, and LLM performance.
It's like we're entering a new era of like LLM design, one where we're moving beyond the brute force approach of just scaling up models and data sets. And we're starting to understand the intricacies of these systems and how to fine tune them for specific purposes.
Exactly. Yeah, it's a shift from focusing solely on quantity to appreciating the power of quality, both in terms of, data and design. And this research is just the beginning. I have no doubt that we'll see even more creative and innovative approaches to LLM architecture in the years to come, leading to even more powerful and nuanced AI systems.
This has been a truly mind expanding deep dive. We've journeyed through the surprising world of LLMs, explored how data composition and those subtle architectural choices can shape their capabilities. And as we wrap up, I'm left with a sense of awe and wonder at the potential of these systems and the incredible ingenuity of the people who are building and refining them.
I share that sense of awe. And as we continue to explore the frontiers of AI, I have a feeling we're only just beginning to understand the true power and potential of these remarkable technologies.
So, to you, the listener, as you continue your own exploration of this fascinating field, remember that it's not just about size or scale, it's about understanding the intricate interplay of data, architecture, and design. It's about asking the right questions, digging into the details, and appreciating the nuanced beauty of these complex systems. And who knows, maybe you'll be the one to make the next groundbreaking discovery in the ever evolving world of LLMs. Thanks for joining us on this deep dive.